So today I'm going to show you on my Mac how to use the what you can do with the tone measurements. Okay, this is a really cool program. It's really simple. So the first thing is I have my frequency generator over here. You can see it. It's not on. When I turn it on, right, I've got it hooked to my speaker here, so you can hear that annoying buzzing sound, which really bothers my wife. It like really irritates her. So, but if you've ever done this, if you hook your frequency generator to just a simple speaker like this, you can get it to make this really annoying noise. So that's pretty cool, right? Because we're making a sine wave. And I'm gonna. Well, that's as. I can't make it any quieter, unfortunately. So I'll just turn it off now until we're ready to go. So what I'm going to do is we want to measure our frequency. Okay, so if you're using LabVIEW and you have a DAC card, okay, it's really easy to measure the frequency because you can use the tone measurement VI and everything works beautifully. Okay, and I'm going to try and do that right now. So I'm just going to make a really fast program. I'm going to get a while loop here. Okay, and I'm going to do create control. So I've got a stop button, and I'm going to go to my input, and I'm going to go to acquire sound. Okay, so literally, I'm going to say, okay, my duration will be here. I'm going to go to 0.1 seconds, and I'm going to do one channel. And this is just the built-in microphone on my computer, and it can go up to 80,000 hertz, okay, which is really good. And then over here, I'm going to go back up to Express, and I'm going to go to Signal Analysis, and I'm going to go to Tone Measurement, okay? And this is the one that I've been wanting you guys to use, so I'm just going to do my frequency here, and I'm going to click OK. We're just going to do a frequency measurement, and I'm going to wire this right into here, okay? So, and now I'm going to right click here, and I'm going to do create indicator, numeric indicator. That's just going to give me the frequency as a number, and this is going to be in hertz, okay? So, and I'm also actually because it's cool, I'm going to click here and do create a graphical indicator, okay? And when I do that, I'm going to drag it over here, and this will allow me to visualize the sound waves, okay? So first thing, I'm going to turn this on, and it doesn't have enough data points to actually see anything. I'd have to take data for longer because this is in seconds. But I can turn on my frequency generator now, okay? And you see here it says 883, and that's the frequency that I'm measuring. So if I go up, okay, I go to, it says 18 kilohertz when I don't talk. When I do talk, so it matches the frequency generator, okay? So if I want to visualize this better, I'm going to go here to tone measurement, and I'm going to put, under acquire sound, I'm going to put this 1 second, which will allow me to see it on my graph. Okay, so I'm going to go E here, and okay, it still doesn't work. That's okay. I'm just going to... okay. Okay, so the frequency matches my signal generator, except when I talk, then it changes. Okay, so I'm going to hit, you can see this number here. So it matches my signal generator. And I can go up to 20,000. Mm. Okay, so it's getting 16,000 kilohertz, which is, right, maybe if I put this closer to my speaker I could get, let's see if I can get above. Wait, don't type. Don't make any noise. No, there's too much background noise. I can get 12,000 hertz, okay? So, but the point is that I've got a very simple program that does the tone measurements, okay? That was really easy, okay? But, unfortunately, with your Arduino card, it's not that easy, okay? And the reason is because this tone measurement VI only accepts data if it's in dynamic data or a waveform, okay? Because what happens is, if you don't have it in a waveform, it just goes in as two disconnected data types, okay? And you also have to send it a time signal, okay? So, were you guys keeping track of the time signal you were sending into the tone measurement VI? Yeah. You were? And did you have it as a just as an array, or did you do a waveform?
Waveform.
You did a waveform.
I created a waveform. I mean, it's accurate. We can see. So now, if I like this, it's pretty accurate.
But the Nyquist frequency actually depends on your whole system, right? Because you are only able to get data from your Arduino card into your computer so fast, okay? And your when you get into LabVIEW, that's the thing that's actually adding the timestamp for you, okay? So what that means is that your Nyquist frequency is going to be super low, okay? So did you get to a place where it's the frequency is accurate up to a maximum value, and then it goes lower again, right? So that was the curve that we were talking about that you can see on Wikipedia, where it's accurate up to a point and then it drops off again. And just because of the way that we're doing this with LabVIEW, then the Nyquist frequency for your Arduino card is actually going to be pretty low, like you found. Did you also get the waveform to work? Do you want me to go through it real quick?
Sure.
Do it with you guys? Did you do that too?
I didn't finish it.
Okay, so you can actually finish your lab then. You can actually get actually start taking data and just try and finish it and get your lab right up done. Okay, and if you want to help these guys, that would be great too. But just do your lab. Okay, so now you guys, are you able to actually read the data with your computer? So you're able to read just basically a number, right? Okay, so let's go here and let me log into the thing about the Arduino program is you don't actually have to convert it into a voltage to get the frequency, right? Because I found that the quickest way that the Arduino card can read a voltage is if you use this this type of variable right here. It's called uint32_t, and this is the fastest operation that I've been able to find so far. Okay, so if you use a double variable, that's actually a very slow procedure on an Arduino card, and it actually takes some of the processing power from your Arduino card. Okay, so if you want to make it go faster, use this uint32 for your sensor value. Okay. And I'm gonna go here to Okay, so the program that I actually ended up going with, all it does is it just reads the sensor value right here. So it's got analog read from channel A1, okay, and it just puts that into sensor value, okay. And then I made another variable here, and I said uint32 equals volt, or volt equals 0, and I said volt equals sensor value, just like that, okay. And then down here, all I did was I just said serial print line volt. Okay, so I'm not even doing a conversion in the Arduino software. I'm just taking that value from the buffer and sending it straight to LabVIEW. Okay, because if you actually try and do that operation on your Arduino card, it's going to actually slow it down. Okay, now, so you can just have a real simple Arduino program, and all it's going to do is just going to send numbers to the serial port. Okay, so, and the other thing is, I set my baud rate up here to 115,200. Okay, and this is what I found online is the maximum communication rate between your Arduino card and the computer. Okay, so I believe that this is the fastest. You might be able to send it faster, but I don't know. Okay. So you could try different values, but I know that this one works because I've been testing. Okay, so this is my Arduino program. Okay, and then here, let me open this program. Okay. Okay. So, you guys have, you guys should have this part right here. Let me go to context help. Okay. So, you have this part here where you name your Visa resource, right? You have that one, okay? So, and you should have this baud rate one, right? So that's specifying your baud rate here, okay? And for my baud rate, I put again 11,500 and 115,200 for the baud rate, okay? That's a communication port. That's the speed that you communicate over the serial port. Okay, so you can go ahead and step that up. Okay, then on my my front panel. Okay, so you should also have this read Visa part. Do you guys have this part here? The Visa read. Do you have that in your program? You guys have that part, right?
Yeah.
Okay. So this thing was giving me problems because it was having some type of communication error. And so this little pop-up window would come up every time. It was extremely annoying. Okay. So what I did is there's an air out function here. So if you mouse over this, it says air out in the bottom right. I'm going to right click on that and do create indicator. Okay. And all that does is it's going to put a little window on the front panel here, and all your error messages will go there. And so it will stop LabVIEW from creating this super annoying pop-up window. Okay, that's all it does. And so you should definitely put that in there. And if you want to, you can actually right-click on it, and you can go hide indicator. Okay, so if you don't care about it and you don't want to see it anymore, just go hide indicator. Okay, so that means that when you run this program, the user is not going to see any errors that occur. Okay, then, okay, so you guys have that part, and also on this decimal to string number here, do you guys have this part? Decimal to number string. Okay, I created a constant. Right, I right-clicked here, and I said the default value. I go create constant. Okay, and on my constant, I'm going to right-click and go to properties, okay? And I'm going to go to data type, and I'm going to hit double, okay? Because you were having this problem where if you don't do that, it truncates all the decimal places and you lose everything in LabVIEW. Okay, so put this as a double value, okay, and make sure that over here, this part over here, that's also a double constant. Okay. Now, you should also have this part here where you're going build array. Do you guys have that? Do you have the build array here? Okay, so you're starting to build up an array and you're getting all the values that you've been collecting, right? And then you say, okay, well, how big is this array that you're creating, right? So you go to array size, okay, and all this is going to tell you is how big the array is, right? And you want to get the latest, the most recent values coming into your array, because as you run this program, your array is just going to get bigger and bigger and bigger. So if it gets too big, your program might crash. Okay. So you're going to take this value here from array size and go into this subtract function. Okay. And you do subtract 50. Okay. That gives you the array size minus 50. Okay. And so that's going to be the latest value minus 50. And you're going to pass this over into array subset. Okay? And then you're going to run your array over here, and you're going to put this constant value 50. Okay? So what this is doing is it's returning the latest 50 values from this big array. Okay? And that's what all of your frequency data is going to be based off of. Okay? So now, if you want to get lower frequencies, okay, you could actually make this 100 right here, okay? Because remember, if you get to too low of a frequency, you're going to have bigger arrays because you won't have one period. So if you get to really low frequencies, then it's going to mess up because LabVIEW won't know how to handle it, because this array needs to be big enough to get to handle whatever the frequency is. Okay. So now the key here, and I sent you a link. Did you guys get this link about the build waveform?
No. No.
Did I not send you a link about it?
I did not get it.
Okay. Well, let's talk about it right now. Okay. So this VI is called build waveform, and in order to get your tone measurement VI to work, you need to put your data into a particular type of variable called a waveform. Okay, you can read about it here. This is your build waveform. Okay, and you're gonna pass your array into here, right? So whatever array it is, okay, you're gonna pass it into here, and it's gonna put it in this particular type of data called a waveform, because the tone measurement VI only works if your data is in a waveform. Okay.
I think the reason it was not working is because, I mean, we can send arrays to the tone measurement. You can still measure it, but I think that you were right about the timestamp thing, because the system just made up like random timestamp to the signal point. That's why we need to like stamp.
Exactly. Yeah. See, that's exactly the whole point. Is what this build waveform gives you is it allows you to control what the timestamp is on your data. Okay, because what do you need in order to compute a frequency? You need a time, right? You need the amplitude, and you need to know how far apart each one of those amplitude points was in time, right? Because you need to know basically how long one period is, right? So what this gives you with your dt here, this value specifies how much time has passed between each of your amplitude data points. Okay? And this, I made it controllable by the user, and so you have to basically put in your own value here to get it to match the frequency generator.